Okay, so this is a continuation of 10.2. So you could consider it 10.2b. That would be fine. And this is going to be area of rhombuses and kites. And if you think about rhombuses and kites, so just be aware that it's 10.2b. If you think about rhombuses and kites, they're just comprised of triangles, right? So the area of a rhombus, is going to be this formula here, 1/2 diagonal 1 times diagonal 2, and that's the same for a kite. So they're going to be the same thing in this situation. So what's happening, I guess, is if you think about any of these, so let's take a kite for example. Let's make it look something like this. Okay, so it looks similar to the one there. And let's grab a bunch of different numbers. So let's call this 3, 4, 5. And then let's see, 4. I guess we'll call this 4√3, and then we'll call this 8. Okay, so that's what we have. The first thing we know about this is that these are all kind of congruent. Oops, sorry. These are congruent like that. We have a 90-degree angle here. So let's look at this kite for a second. Before we just do this formula out, I kind of want to look at why this makes sense. Well, I'm just going to grab two of the triangles. So the first thing I'm going to do is I'm going to grab this triangle right here. So that triangle looks like this. It's 4 here, it's 3 here, it's 5 there. What's the area of that triangle? Well, that's going to be 1/2 of 12. Okay? And there are actually 2 of them, so we would double that, right? So if we think about it, this area is going to be 6, and this area is going to be 6 at that point. Then we have this other triangle down here that we have, and I'll flip it around so it looks like this instead. And that is 4√3, and 8. So that area is going to be 1/2 base times height. And I guess that's going to come out to 8√3. So this area in here is 8√3, and this area is 8√3. So the total area, if you take all of these things and you add them up, right, you've got 12 plus 8√3 plus 8√3 is 16√3. So that's going to be the area of that shape. So it's just based off a bunch of triangles, right? So I'm going to erase and just kind of show you what happens here. Okay? Just kind of show you how this makes a lot of sense to me. Why does it make sense? Well, we want to focus on this formula right here. That's important. So I'm going to put it down there, put a quick circle around it. That's what we're going to use now. So if we go and we take this shape, okay, and it's incredibly messy, but hopefully you can bear with me and remember that it was this. That was 4 and 4, so this whole thing across is 8, all the way across. And this was 3 and 4√3. So it's kind of an annoying number, but this whole distance here, this thing, is 3 plus 4√3. Okay? So what the area should be, according to this formula right here, according to this formula, let's give ourselves a little space, is it should be, this area should equal 1/2 diagonal 1, which I guess is 8 in this case, times diagonal 2, which the whole thing was 3 plus 4√3. Sorry for the numbers that go like that. So 1/2 of 8 is 4. And if you now distribute, you have 12 plus 16 root 3. So you'll notice that we found the same area no matter how we did it. So moral of the story is you can use this formula in the green circle, bottom center here, 1/2 diagonal 1 times diagonal 2. That is the entire diagonal here all the way across, and then this entire diagonal here. This is for a rhombus or a kite, it will work. But that's only because it's based off of triangles, so it's a simplification of that mess that I did in the beginning. And it makes sense if you really think about it. 4 triangles will actually work out to give you that green circle, in a sense. So take a look at this one, and why don't you do the now you try. So here's the area formula, in case you need it. Actually, why don't I do one, and I'll let you do the other. So this is the now you try. And then this one here I'll do for you. So it's going to be area equals 1/2. Diagonal 1 is this whole length, which is 6. Diagonal 2 is this whole length, which is 7. So that's going to be 42 divided by 2, and that's going to be 21 units squared. In this case, it's meters squared, so I'll change that into an M. So 21 meters squared. So pause the video and try this one, and I'm just going to stop it here in the interest of time.